Hello everyone. Today we're going to talk some more about parallel lines and what happens when transversals cut through them. First off, just some review from the investigation that you did yesterday. So anytime you've got two parallel lines and they're cut by a third line called a transversal, then these are the relationships that we can know for certain. First off, any pairs of corresponding angles are always going to be congruent. Alternate exterior angles are also congruent. Alternate interior angles are congruent as well. And last, consecutive interior angles are supplementary. They're the ones that are different from the rest. And just remember that supplementary means they add up to 180 degrees. All right. One other theorem before we look at some examples. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other one. What this is saying is, if we have two parallel lines, and what you'll notice in the following examples is many times to indicate that they're parallel, they'll add an extra pair of arrows on them, indicating those two lines are parallel. Anyway, if you've got a transversal that cuts through or intersects both of those lines, if we know it's perpendicular to one of the lines. So for instance, let's say I know that it's perpendicular to the top line. Well, that means I know that it forms right angles. So we've got a right angle there. Well, if you look at this angle, I'll call it angle 1, and this angle down here, which is angle 2, those two angles happen to be alternate exterior angles. Once again, that's not your bell. So those are alternate exterior angles. Since the lines are parallel, alternate exterior angles are congruent. If they're congruent, that means they both have to be 90. So this would have to be a right angle as well. Well, if that's a right angle, then the transversal is also perpendicular to the bottom line. So basically, if the transversal forms one right angle, all the angles are going to be right angles because it's going to be perpendicular to both lines. Okay, let's look at some examples. First two examples here, we want to find the values of both x and y. In the first example, we're given an angle that's 77 degrees, and we want to solve for x. Well, if you look at 77 and x, those two angles, they are actually a linear pair of angles, which we learned about in the first chapter, which means that they add up to 180 degrees. So I take 180 minus 77, and I get that x is 103 degrees. I now want to compare x to y. X and y are in the same relative position. In other words, x is in the top left corner from its intersection point, and y is also in the top left corner from its intersection point. That means that those two angles are corresponding angles, and we know that corresponding angles are congruent. So if x is 103, that means that y has to be 103 as well. All right, let's look at the second example. Once again, we're going to try to find x first. If we look at x and 125, those two angles there, they both have the same vertex point, the same intersection point, and they're located across from each other. Once again, that's back to the first chapter. Those two angles would be vertical angles. Vertical angles are congruent. So that means x is going to be 125. Can't forget about vertical angles and linear pairs. They'll still come into play. Now, if I want to figure out what y is, I have to compare x and y. X and y, those two angles there, are consecutive interior angles. They're both located in the interior section of these parallel lines, and they're consecutive, which means they're on the same side of the line. They're both above the transversal. And one thing we know about consecutive interior angles is that they're supplementary. Supplementary means add up to 180. So to get y, we're just going to take 180 minus 125, and that gives us that y is 55 degrees. And we've now solved those problems. On to the next two examples. Now we just want to solve for x. In the first example, notice that we have a right angle. That tells us that that line is perpendicular to the top line, top parallel line. And from the theorem I stated a couple slides ago, that means it's going to be perpendicular to both lines. Which means all of the angles in this problem are going to be right angles. They're all going to be 90 degrees. Specifically, this angle down here is going to be 90 degrees as well. Well, if it's 90 degrees, but it's also 3x minus 6, then we can just say 3x minus 6 equals 90 degrees. Now all we have to do is solve for x. So I'm going to add 6 to both sides. I get 3x equals 96. Divide by 3. And x equals 32. Now, sticking with that same problem, you'll notice that those two angles, the original 90-degree angle and the 3x minus 6, are not one of the pairs that we've studied. They're not corresponding, they're not alternate interior, they're not alternate exterior, they're not consecutive interior. They're on the same side, but they're exterior. Some people might call them consecutive exterior, but that's not really correct. So we did not know initially what their relationship was, but since we had a right angle, we know that they're all right angles. All right, let's look at the second one on this slide. We've got 8x plus 10 in the top right corner. We've got the 114 in the bottom left corner. They are both exterior angles because they're outside of the parallel lines. They're alternate because they're on either sides of this transversal. One's to the left, one's to the right. So that means they're alternate exterior angles. And what we know about alternate exterior angles is that they are congruent. Anytime angles are congruent, you're going to set them equal to each other. So you're going to write 8x plus 10 equals 114. You're going to subtract 10 from both sides, and you're going to get 8x equals 104. You're then going to divide by 8, and you'll get x equals 13. And that's your answer. So the goal, if you can, is to try to identify what types of angles they are, and then figure out, ignore the bell, figure out that whether they're congruent or supplementary. If they're congruent, you'll set them equal to each other. If they're supplementary, you'll add or subtract from 180. All right, last example. We want to find the value of y. Now, the 37-degree angle and the 15y minus 7 are not one of our pairs of special angles that we've learned about so far. So we don't know right away whether they're going to be congruent or supplementary. So what we need to do is figure out another angle we do know. Well, you can pick lots of different angles here, but for example, 37, this angle right here, and that angle that I've highlighted with the blue dot, those two angles are going to be corresponding angles because they're both in the bottom right-hand corner of their intersection. Well, corresponding angles are congruent. So that means that this angle down here is also 37 degrees. Now we can compare those two angles. Those two angles are a linear pair, so they add up to 180. Anytime they add up to 180, we're going to add them. So 15y minus 7 plus 37, and we're going to set them equal to 180. equals 180. And we're going to solve from there. Combining my negative 7 and my positive 37, I get 15y plus 30 equals 180. Subtract 30 from both sides, we get 15y equals 150. Divide by 15, and y equals 10. That's our answer. Notice that once again, we did not know the relationship between the two angles. So if you end up with a pair of angles that is not one of the angles that we've studied specifically, one trick is, you can just memorize this or jot it down, is if we do not know what pair of angles they are, then they are always going to be supplementary, which means they add up to 180. So if it's an unknown pair of angles, they're not corresponding, alternate interior, alternate exterior, consecutive interior, then there are going to be a pair of supplementary angles. So you know that they're going to add up to 180. That's it. You'll now have an assignment that'll give you some practice with this.